Hello viewers, welcome back to the channel Maths with Berlin. So today we will be sharing a problem on limits as well as integration. So this problem is basically a prediction for future competitive exams, not just IIT. So let's get started with the video, and those who want to try the problem without my intervention, so they can just pause the video right here and give it a try. I would suggest giving it a try. This would help you to enhance your thinking skills and also help you boost your motivation. So let's get started with the video. So it is given that we have to find a real number C and a positive number L for which the following limit holds true, right? That is the actual question that is given to us. Now this looks pretty nasty, right? This integration and this limit, that is r tending to infinity, although the limit is not so bad, but the integration part is very nasty because x to the power of r it is given and r is tending to infinity. Also it is just like x, not just x to the power of r, it is also x to the power r into sine x, which is making it more difficult. Now I will be just moving on to the hints so that it's better for you all. So for the first hint, as you can see, we have taken out an inequality, and that is 2 pi by x and x, about like it is sine x is less than or equal to x, and it is always greater than or equal to 2 by pi into x, right? So I will be sharing the graph with you all right now. So here is the graph, as you all can see. So let me magnify the graph for you all. So as you can see, this is the sine x curve right now, and as marked on the screen, right? This is the sine x graph, and this is the 2 pi by x graph, and this is the graph of y equal to x. Now how do we say that it is equal? It is always less than, and it is like sine x is always in between. You can obviously see that, right? And this is only varied up to wait a minute, yeah, this is only varied up to pi by 2, like it is only varied from 0 to pi by 2, right? This inequality is valid from 0 to pi by 2, as you all can see, and we can also prove that, but I am leaving the proof up to you. Also knowledge of fact, right? Just for general knowledge, you may know that this inequality is called as the Jordan's inequality. This is known as the Jordan's inequality, right? And now after that we have the squeeze theorem or sandwich theorem, which I think obviously you will be knowing. That is limit of x tending to a if f of x, for f of x, let us say that it is equal to L, and limit of gx tending, for x tending to a, is equal to L, then what we can say is that if f of x is less than or equals to hx is less than or equal to gx for some function hx, right? It may be any function, doesn't matter. Then we can say that the limit of x tending to a h of x is equals to L, right? This is what we can say. This is the sandwich theorem or squeeze theorem. So now after this we move on to the solution, and before that I would like everyone so that they can try the problem right now by the help of the hints shared, and for those who have tried it or those who don't want to, they can move on to the solution. So let me just guide you all through it. So first what we have done is we have taken out that the Jordan's, by the help of the Jordan's inequality, what we have done is we just multiplied this term. We tried to evaluate this term right here by multiplying x to the power r on both sides. So this term right here ends up as 2 by pi into x to the power r plus 1, and the term on the right hand side ends up as x to the power of r plus 1. This is just basic mathematics. After that, what I have done is I have just applied the integrals. We can do it, right? We can apply the integrals just because the graphs are always increasing. They are increasing, or actually not because that they are increasing, it is because they are monotonic. Actually, either the graph must be monotonically increasing or the graph must be monotonically decreasing, right? That is the only thing that you need to take care about, that the graph must be monotonically increasing or decreasing. Now as it was given that the value, that is r, is tending to infinite, right? So it is a positive quantity, I suppose so, right? Infinite, let us say, according to the limits problem, it is positive quantity, right? So it can take that x to the power of r is increasing function for 0 to pi by 2. This is obviously for all 0 to pi by 2. Right, let me just mention down the limits, otherwise you will apply it in some other problems and it will not be applicable there. So after that, what we do is we just try to evaluate this one. I just replace it with I1. This is the numerator part, and I replace it with I1. And this, for this one, it is just basic mathematics, that is integration of some functions, and this one also is a basic mathematics term, right? Now after that, what we get is that on simplification, so this is 2 by pi gets cancelled out with this one, and so it results into this and this terms. Now you cannot say that from here only, you cannot say that I1 must be some particular value. There is no particular value for I1, right? You cannot say anything about I1. So let us try to evaluate I2, that is the denominator part, right? This part of the question, let us try to evaluate this part, right? The denominator. Now for the denominator, what we can do is, when we take cos of x, now we know that sine of x, sine of pi by 2 minus of x is equal to cos x, right? So what we do is we apply the values of pi by 2 minus x in terms of x. So after that, what happens? This integral that is there for x to the power r into cos x, this does not change, right? Let me just mark it down for you. That is this part right here, the following function doesn't change. So we have to just multiply x to the power r on both sides, right? We have to just multiply this x to the power r on both the sides. Now after that, we just try to simplify it down by opening these brackets, right? We just open this bracket right here and this bracket right here. We open these brackets and then simplify it out. After that, we follow the same steps as we have done on the previous part, that is applying the integral, and this one also is a monotonically increasing function, right? So that's why we apply the integrations. Now after that, what we can do is, we have just simplified these values of the integral and we named that the denominator as I2. Now the given question, in the given question, it was given as numerator I1, numerator equal to I1 and denominator equal to I2, and the given question that was there, that is r to the power c I1 divided by I2, right? So we try to evaluate I1 by I2 first out of all. So I1 by I2 comes out to be this value. See, it's very easy and very simple, right? So you all know it, right? What will be the value of I1 by I2 right now? So that's the beauty of mathematics, that we don't know the value of I1 particularly, we don't know the value of I2 also particularly, but we do know the value of I1 by I2, that is 2 by pi into r plus 1. Now what we can do is we multiply r to the power c and try to apply limits. So the limit will only exist if this r is in the denominator, right? And there is only one constant term. So constant term can only come when c is equal to minus of 1, right? It can only come when c equal to minus 1, and at that time L is equal to 2 by pi. So that's the question for today. Thank you everyone. I hope you like the video and you will obviously like this sum. There's no doubt for it. This was a great problem indeed, a beauty of mathematics shared. So that's it for today. We'll always share these kinds of problems so that it helps you evolve your thinking. And please do solve the problems, and if you can't solve it, please see the solutions. Thank you everyone.